In this video, I want to go over the electrical plan, and I'll try to do it fairly quickly, but there's just so much detail that I'm going to end up leaving out, but I'll cover those in other videos. But here, what I've got is all this purple stuff on the right here. These are the various components that I want to power, like lights and fans and etc. And on the other side, I have green things, and those are things that will provide power. And then I've got a bunch of blue stuff here, which are components that will help me get the power from the green things to the purple things. So, with me so far? The black lines here represent 120 volt AC power cable, 12 gauge, and the red lines represent positive DC. Now, some of it's going to be 12 volts, some of it's going to be 24 volt, but it's all DC and it's all positive. The negative I left out for the sake of simplicity because it's going to take pretty much the same routes, just not through like the fuses and stuff. Oh, and I've left out all the grounding because I'm not entirely sure how to do that yet. I'm still learning that one. But again, another video. So I guess we'll start at the bottom. So on the bottom left, we have a couple of possible power sources of power. We've got service connection, like say an outlet at my house, or the service at the campsite that we might end up in, that sort of thing. And if that's not available, I do plan to buy a little generator to plug into the system. One or the other will be able to plug into a 30 amps inlet, which will feed a little AC sub panel with a couple of 20 amp circuit breakers in it. And the bottom circuit here is the simplest. It will feed a convenience outlet that will be on the wall of the trailer in a convenient location. And I may or may not have a microwave. I don't know. I may get a microwave just for fun. I haven't decided yet. But anyway, that'll be a convenience outlet that will only be available if we have power coming from one of these two sources, generator or service connection. The other circuit, this upper circuit, is a little bit more complicated. It's going to branch over to an AC to DC power supply, which is going to feed a charger, which will charge the battery. That same circuit is going to go on to an isolation switch. I've also heard them called transfer switches or changeover switches, but basically it's an on-off-on switch. If you haven't heard of it, if you have, bear with me. So this switch has an out, right? And it has two ins basically, and you can only connect up one in at a time. And before you can switch from one in to the other in, you have to turn it off. That way the two ins never touch each other. They never come into contact. So they're isolated. And so that, very briefly is what I mean by an isolation switch. And then from there, we have an outlet whose sole purpose in life is to feed the mini fridge and the air conditioner. This outlet will be tucked away inside a cabinet, so it's not a convenience outlet. It's a outlet that's there specifically for these two devices, and that's it. There you go. That's the simple part of this whole setup, the AC side. So getting into the DC side, we have solar array, the battery, and the alternator in my little pickup truck can all provide power to a bunch of this stuff too. So the DC side is a little more complicated. So if we start with the solar array, so I'm going to have a 1,000-watt solar array up on top of the trailer, up on the roof, and it's going to come in through a breaker, a DC breaker, and feed the solar charge controller. So this DC breaker is there to protect the controller from the solar array, just in case something weird happens. It also doubles as a convenient place to cut off power from the solar array to the solar charge controller. From the solar charge controller, of course, it takes the power from the solar array and converts it into something the battery can use, and then the output goes through another breaker. It's also a convenient switch to disconnect the solar controller from the rest of the electrical system. Although my understanding is pretty much every manufacturer of every solar charge controller warns that you should never have the solar array connected to the solar charge controller unless there's already a battery hooked up. So if I wanted to shut the solar charge controller off from the battery, I would need to first shut off the solar array. But of course, in the case of some kind of overcurrent emergency, you don't want to, I mean, who cares? Just shut the darn thing off, right, before something catches fire. Anyway, so from there, it comes down to this bus wire right here, and it splits off to the battery and to all the stuff that's going to be running off of this power coming in, right? So the solar charge controller output, the battery, and all the DC stuff are all in parallel. So the battery can power the DC stuff, the solar charge controller can power the DC stuff, the solar charge controller can charge the battery. You know, this is a pretty standard way to set these up. The only other power input I've got before we get into all the DC stuff is from my little pickup truck's alternator. Now, a lot of people have great big pickup trucks with great big engines and great big alternators, and they can feed lots of current into their battery, no problem. I've got a little pickup truck, so I'm going to be pretty severely limiting the amps coming in. But anyway, I'll get more detail on that in a later video, hopefully like a build video where I'm actually putting the stuff together. But anyway, so then yeah, you've got this kind of bus bar going on, and then you've got another breaker, and then you've got the battery. So the battery, it'll have a BMS, and so this, the cable from the breaker will go through the BMS to the battery. So anyway, the point here is that power is going to be going into and out of the battery through this breaker. So I'm going to have to give that a think, because most DC breakers are actually polarized. I may need to think about getting a breaker that is not polarized, or I have to decide which direction I want overcurrent protection happening in. So that's something I'll have to get figured out later. But I do want a breaker which is going to double as a switch to turn the battery off from the rest of the DC stuff for whatever reason. Same thing with this breaker here that feeds all the DC output, I guess, or the output to all the DC things that are going to use the power. Finally, we're on the other side of all these breakers, so we can talk about the rest of this stuff. So the big one is the inverter. It's going to run off of the battery voltage directly. The battery voltage is going to have a range between 29.2 volts and 20 volts, although I'm hoping not to use that entire range, but the inverter can actually run on voltages even wider than that range, so we're covered there. So the inverter can handle up to 3,000 watts briefly, and its output goes again to this isolation switch. This is the other on of this isolation switch, and then of course off to the refrigerator and the air conditioner. So the fridge is a little 1 amp refrigerator, mini fridge, and the air conditioner is a 5,000 BTU window unit. We do have one little circuit that will feed my CPAP and 4 USB power ports. Those can run off of a very wide range of voltages, at least mine can. And so they can run off the battery directly. They don't need to be they don't need to be on a 12-volt system, so it's more efficient to run them off the battery directly than it is to put them through the buck converter. So the buck converter will take the voltage of the battery and convert it down to 12 volts. It can handle up to 30 amps, which is more than enough to run all of the things that I want to run that are 12 volt. From the 12 volt regulator there, we'll have a little bank of fuses, and then each fuse will run a circuit, and each of those circuits will have some kind of switch going on. That is still kind of up in the air exactly where I want to put those switches, and what things I want to switch individually. So, that's going to probably change over time, I'm sure. So that's the basic setup that I'm imagining. I've got all sorts of other things to share. So I think my next video, I'm going to wait until I have something actually physically done to share. Unfortunately, the trailer itself is going to have to wait another month or two because I've got weather considerations, and I've also got one or two jobs that I need the trailer for in its unmodified state. And so once those are done and the weather turns good, then it'll be time to get into the trailer and start tearing it up. So hopefully soon I will have more videos, and I hope you found this interesting, and thank you very much for watching.